Hi, I'm Sean Gannon, and this is Minute Math, and we want to find the side length of square ABCD. We're given this figure that is, well, the square ABCD, but there's some extra information they're telling us here. We have a little diagonal kind of going down here, side length of 4, got a right angle, length of 1, right angle again, 3, that goes to the other corner here. And that's our only clue, that's all we're given here, and we need to determine the side length of this square. So I want you to pause this video and see if you can, well, figure out what the side length of the square is. But if you want to learn something here or you can't figure it out, we're going to go dive on in and, well, solve this problem, show you how to think about this problem here. All right. One of the keys with geometry problems like this is you can add things to the picture with some rules here. So what I'm going to do here is I'm going to create a new point. I'm going to create a point out here, P, and then make a little line that connects P to B. And that line's going to be parallel, if I can draw parallel lines here, parallel to this line segment right here. So, I'll draw a little line, more or less parallel there, meaning that we have a right angle right here. Let's label that point P. And while we're at it, let's go label these, and I went with E and an F. 2 points here. So we made it so that E and F are parallel, line segment EF, to BP. All right. Well, let's go connect P to F while we're at it, and that's really just an extension of line DF. Should be. Rules of geometry here. And what that tells us here, that FP is equal to the same length of EB, if the length is, which is equal to 3. So we got 3 here. Oh, and EF and BP are also equal to 1 by the same idea. So EF is equal to BP, which is equal to 1. And it's a rectangle we see here, so we got some right angles going on right there. All right, now I'm going to draw another line. And the key here is I'm trying to find the length of the diagonal from D to B. So I'm going to do that here, draw a new line from D to B. And it's going to intersect, might clutter up a little bit, so try to take your time, understand it. And we have line segment DB, and we want to figure out what is the length of DB. We don't know what it is, but we know what DP is. DP, that's 4 plus 3, which is a 7. We know the length of BP is 1, and look at that. We got a right triangle here, which good old Pythagoras can help us with that. So we have a 1 squared, that length, plus 7 squared is equal to DB all squared. From there, 1 squared is a 1, 7 squared is a 49, equals a DB all squared. And we have 1 plus 49 is 50. And we take a square root of both sides. Let's just do that here. And we have DB. That length is the square root of 50. So we have the length of DB is the square root of 50. All right, so we have square root of 50 here, but we need to find a side length. But if we know about, well, our square here, this diagonal cuts that angle, the 45 degree or 90 degree angle in half on the corners, right? And so that angle that's created right here and up here are both 45 degrees, okay? So 45 degrees and right here 45. So we can challenge us or tackle it 2 different ways. We can know that it's a 45, 45, 90 degree triangle, or we can use Pythagoras again. I'll use Pythagoras again, but if you want to check me and use the 45, 45, 90 degree triangle idea and see what the side length should be, you should be able to get the same answer. But I'm going to use Pythagorean theorem because AB, let's call that length x, is the same thing as AD, which is also x, which is the side length of the square that we need to find. So x squared plus an x squared equals the square root of 50 squared. That's an easy one because it's going to cancel. I love when that happens. It's always a lot of fun. So we have 2x squared here, adding them up, equals square root of 50 squared, which is 50. Divide both sides by 2. We have x squared equals 50 divided by 2, 25. Square root both sides, plus or minus, can't be negative, don't worry about that. And x equals 5 units. And so the side length of our square here is 5 across the board, right there, and we solve this problem, okay? So the side length of the square is 5 units. Did you get that answer? Did you get the same answer, knowing this is a 45, 45, 90-degree triangle? If you did, way to go. If you learned something here, that's great. That's the whole point of this channel. And so if we want to keep making videos like this, don't forget to like this video and subscribe to this YouTube channel. This helps us make, again, more of these fun math videos for you and for everyone else. So as always here, thanks for watching.